Alright, welcome to Calc 3 this week. We're going to discuss integration again, but now we're kind of moving up in dimensions. So we had mentioned at the beginning of the semester that we were going to kind of explore this semester of Calculus 3 through integration, but by discussing it by dimension. So previously we were discussing line integrals and whatnot, and now we're moving up into 2 dimension, well, actually 3, and discussing kind of volume as our warm-up question says. So I kind of want you to pause the video and see if you can tackle the warm-up question on your own. And that should say rectangle. But maybe you had a chance to pause this video. How I thought of this is, if you think about the rectangle, 1, so maybe you're in 3 dimensions. So okay, if I just make a quick little sketch here, we're in 3 dimensions. We're looking at that rectangle 1, 1, something like that. And then if you were to imagine this plane, if you think about that being under the plane, it would certainly have a maximum height of 1 unit. So it would be kind of this unit box at most, and then you're taking a plane that's cutting through it at a diagonal, and so where z is equal to y, and so you'd have something like a half of a box, and I can't draw that too well here, but so if you have half of a box, okay, that's really saying, okay, well, you have the volume that is half of the unit box, that is. So the unit box, that part is 1 times 1 times 1. I'll get an extra 1 in there, and then we have half of that. So the volume should just be 1/2. Now, is there a better way to do this? This we just use geometry. What about more complicated regions? Well, we're going to talk about that today. And the strategy that we're going to employ might actually not surprise you, but surprise you at the same time. We're going to use ideas from Calc 1. And what do I mean by that? Well, when we talk about volume, or if we were to find a volume, that's really kind of an area underneath a curve, right? So what I did up there, it was a plane, and I found the region underneath the plane. So similar idea to finding area under the curve. Well, we might remember that in Calc 1. We found the area under a curve via an integral. Wrong. We actually started with a Riemann sum. Okay, so that is to say we took the domain that we were on, let's call this A, and let's call this B, and then we split that domain into some number of pieces and created a partition. So we did, like, here's x1, x2, da da da, up to xn minus 1, and then we called this xn, and this is x0, something like that. And we said, okay, well, we're going to, for each of those partitions, we're going to make a rectangle that approximates the area, and we used different endpoints, midpoints, left, or midpoints, left to right endpoints, that sort of thing, and then we ended up taking a limit, right? So that's kind of the idea that we're going to proceed with today, is doing a lot of Riemann sums and limits. And don't worry, we will jump forward to integrals at some point. All right, but that's just an overview of what's to come, and we'll kind of dive in the next video.